This is a tutorial on the categorical logic exam. In this tutorial, I'm going to work some samples of problems from each of the problem sets, and then at the end, I'll post a link to the key for the complete exam so you can see answers to all the problems. So let's start with section 1.1. These are immediate inferences, so obviously we have only two circles because we're talking about an immediate inference between two terms that proceeds from one proposition to another proposition. So the challenge in this is to determine the validity of each of these inferences using a Venn diagram, and also to discuss Aristotelian and Boolean conflicts where they arise. So let's look at the very first problem. The first problem is sum S is not P. So we'll start with sum S is not P. That's the premise. Therefore, sum non-P is not non-S. All right, so for those of you who practiced on the mechanical transformations, you might notice that this is the complement of the predicate term moved up to the subject position. Here's the predicate, that's non-P, and the complement of the subject term moved to the predicate position. Everything else is the same. It starts as an O, it ends as an O, so this is a contraposition on O, right? So let's have a look. Sum S is not P is a particular proposition. There's no shading, so all we have is an X. And for this diagram, we're going to have an X outside the region of P. That's sum S is not a P. So now the question is, does this diagram require the conclusion to be true? A lot of the trick for the conclusions where you have complements is just being able to read them so that they make sense, right? So think about this. There's at least one thing, that's the sum. There's at least one thing outside P that is not outside S. So think about what's the region outside of P. It's just everything outside of P. So there's at least one thing outside of P. So yes, we have at least one thing outside of P. And so is this X that represents the one thing outside of P, is it or is it not outside S? Well, it's inside S, so it's not outside S. So the X in the diagram does accurately represent sum non-P is not non-S. So this problem, this diagram shows that this inference is valid. Okay, good. Let's do one with, I'm just going to add and hide layers. Let's do number 4. Number 4 is no S is P. Therefore, all P is non-S. All right. So now, in terms of mechanical transformations, this was not required in the exam, but it's just interesting to notice this because that gives us a parallel method for checking on validity, right? So the converse of no S is P is valid because the conversion on E is valid. So that means if no S is P is true, then no P is S is true. And if no P is S is true, then the obverse of that, all P is non-S, is true. So using the mechanical transformations, we have an expectation that this is going to turn out to be a valid inference. So let's find out with the diagram. So we have S and P. We have shading because the premise is universal, and the shading is the region of S overlapping P. So we'll shade this region. Okay, let's consider it shaded, all right? Now, because the conclusion is also universal, we don't have that pattern that makes us concerned about the Boolean versus Aristotelian interpretation. What is the pattern? The pattern is all universal premises with a particular conclusion. In those situations, it's an existential fallacy on the Boolean interpretation, and with the Aristotelian, we just have to work it out to see if it's valid. It may or may not be, right? But in this case, we don't have that pattern, so we don't have a conflict. The immediate inference goes from universal to universal, so we're set, right? So now all we have to determine is whether this diagram requires the conclusion to be true. So let's look at what the conclusion says. It says everything that is a P is outside of S. Now let's think about this. Where's the region of everything that is a P? Obviously, it's everything in the P circle. And because of the shading, everything that is a P is also outside of S. And that's because the region of S that would have been inside P is empty because of the shading. So this inference is also valid. Okay, good. Now let's do one more where let's do number 3. This is all S is P, therefore some P is S. Now what do we notice about this? Well, it meets that pattern for triggering a concern about the Aristotelian Boolean interpretations. In fact, on the Boolean interpretation, it's an existential fallacy. There we go. It's an existential fallacy. So what we need to do is figure out whether it is valid or not on the Aristotelian interpretation. And to do that, we have to do a diagram. But to do this diagram, we have to do the Aristotelian version of this diagram, right? So here we have S and P. All S is P, obviously, is universal because it meets the pattern for existential fallacy. So we're going to shade, and we have to shade the region of S outside of P so that it's empty. There we go. That region is empty. And now, as you might remember from the Aristotelian interpretation of these propositions, Aristotle assumed that there's at least one of each of the terms that we're operating with. So there has to be at least one S and at least one P. And what we can do is put an X right here to indicate that there's one of each. There's at least one S because that X says there is, and there's at least one P because that X is in the region of P as well. Now, because this Aristotelian interpretation requires the X, now we can ask whether the placement of the X in this diagram requires the conclusion to be true. In other words, does this diagram require it to be true that there is at least one P that is an S? And the answer is yes, it does, because this X is a P that is also an S. So on the Aristotelian interpretation, this inference is valid. And that's the complete answer. There's an existential fallacy on the Boolean interpretation because there would be no X in the diagram on the Boolean interpretation. And with no X, some P is S couldn't be true no matter what, right? But with the Aristotelian interpretation, we do have an X. Since it's affirmative, we only need one X to show that there is at least one member in the subject term, S, and one in the predicate term, P. And it just so happens, because of the placement of this X, that it requires the conclusion. So on the Aristotelian interpretation, this one is valid. Okay, good. Now let's move on to the next section. This is the section that has to do with the various issues on the square of opposition, right? And so let's look at the problem. So we have two of these. That's kind of a strange square, but it'll do, right? So if E is true, so here's our starting point. If E is true, by contradictory, the corresponding the corresponding I has to be false. And as you know, contraries cannot both be true, so the corresponding A has to be false. And if E is true, then the sub-implication or subaltern is true. And so there's our square. If E is true, then the corresponding A and I are false, and the corresponding O has to be true. Now let's look at the second problem in that, which is if O is true. So here we start down here. This is our starting point. Contradictory is going to work out okay because they work for any interpretation. But now what about the E? We can't go up from true to true. When we go up, super implication, when we go up, it's always false to false. We do know the truth value of the A, but these are contraries. The A and E are contraries, so contraries cannot be true, cannot both be true, but they can both be false. So this doesn't really tell us enough information about how to determine what E is. So it's indeterminate. And it should be obvious if this is indeterminate, then its contradictory must be indeterminate. But let's go ahead and think it out, right? So we could do subimplication, but the A is false. So we can't do it going down false to false. That only works true to true. And subcontraries down here. Contraries cannot both be true, but subcontraries cannot both be false. So look what we have. We have a true, but that's not enough information to tell us that the corresponding I has either true or false as its value. So based on both lines of reasoning, I mean, obviously with contradiction, if we've got one indeterminate, the contradictory has to be indeterminate. But based on both lines of reasoning, we see that if O is true, that's our starting point. If O is true, then the corresponding A has to be false, and the E and I are indeterminate. Now let's talk about this whole issue here, because what both of these illustrate is how the square of opposition behaves on the Aristotelian interpretation. But when we switch to the Boolean interpretation, what changes? What changes is only contradiction remains. No other inferences still work. So what that means is this one doesn't change at all, because the only value we got out of it was a contradictory in the first place, right? This one, however, the first one, that's going to change. If we start with E being true, we will get to keep the corresponding I being false by contradiction, but you don't get to keep the other inferences, subimplication, superimplication, contraries, subcontraries. So the main answer you could give to 1.2.2, how would the answers be different? The answers would be different because only contradiction survives, right? Now, talking through some of these problems, under 1.3, number one was about contraposition. So remember, contraposition does not change the quantity and quality. It only changes the subject and predicate term. We swap the complements of the subject and predicate term. So if we start with a particular negative, that's an O, that some S is not P, the contrapositive of that is some non-P is not non-S. And so the correct answer is D. A is tempting, but it leaves out the negation. In other words, we've changed too many things for this to be a genuine case of contraposition, right? If we apply contraposition to universal negative, contraposition is only valid for A's and O's. So if we apply it to anything else, it's invalid no matter what interpretation you give. So the correct answer is A. Conversion, I think we noticed this a moment ago. Conversion is valid for E's and I's. And distribution, yeah, let's look at the distribution here. So if you remember our square of opposition discussion, the distribution pattern goes like this. For A's, it's distributed subject, undistributed predicate. For E's, it's distributed and distributed. For I, it's undistributed, undistributed, and for O, it's undistributed subject, distributed predicate. So this last problem is which of the following have distributed subjects? So we just look for subjects to being distributed. Here it is, and here it is. So the correct answer is both universal propositions. All right, good. Now let's move on to categorical syllogisms. I'm going to make my empty schema visible, and we'll just keep using that over and over again. Okay, but I don't want to write on it because I want to preserve it. All right, let's have a look at, let's look at the very first problem. Some P is not M, all S is M, therefore some S is not P. So you have to do several things in the instructions. First, we have to give the mood and figure based on this schema, and so the mood and figure is O. Whoops, let's go back here to the whoops. Let's see. Oh, there's the draw layer. Okay, now we need to be writing in that draw layer. Okay, so the mood and figure is OAO2. Okay, so if you have a look there, I should have done the schema. So the schema is some P is not M. The minor premise is all S is M. And the conclusion is therefore some S is not P. Okay, so if you notice here in where the M's are, we have the second figure. So the figures go like this. So if the M's are in that shape, it's figure 1, here's 2, here's 3, and here's 4. Okay, so this is shorthand for that system of remembering where the M's are. So the M's would be everything would be populated like this in each of the 4 quadrants. Okay, so the first thing we need to do is determine the mood and figure. So we've done that, OAO2. That's because this is O, that's an A, this is O, and we have the second figure. Second thing we need to do is construct a Venn diagram for this. So we've got our empty schema. Across the top we have S and P. Hanging down there we have M. The first thing we want to do is shade. We want to do all our shading. Only the minor premise is universal, so that's where our shading is going to be. All S is M. So we're going to shade the region of S outside of M. And remember, we're going to ignore the P circle because P doesn't have anything to do with the relationship between S and M in the minor premise. It's just between the minor and the middle term, right? So the shading is going to cover the 2 regions. So we just ignore the P circle. Okay, there's no other universal, so there's no other shading. So now it's time for us to put X's on there. So what we want to look for is definite X's. So the obvious X we have is for the major premise because it's a particular. So we need a P that is not an M. So the P that's not an M, it is a definite X. Look why. It's a definite X because it's in the region of P outside of M, and because of the shading that we previously put on for the relationship in the minor premise, there's only one region for it to be. It's the region of P that's outside of M and outside that empty part of where S overlaps with P. So that's a definite X. So that's it. There are no other X's for us to put on. Since there are no other X's to put on, we're ready to ask the validity question. Does this diagram force the conclusion to be true, or require it to be true, or necessitate that it's true, whatever your favorite way to think about it is? So the conclusion says something about an S that is not a P. Where would that be? The only region where it could be is this little piece right here, the region of S overlapping M that's outside of P. It has to be outside of P. And notice that region is empty. The only X we have is way off over there. It's not even an S. So it tells us nothing about the truth value of the conclusion. Let me make a point here, though, that can sometimes be confusing. This diagram does allow the conclusion to be true. It could be true, but if it is true, it only happens to be true. It's not like required to be true by the 2 premises. So we want a really strong relationship here. The diagram has to require or necessitate the conclusion is true, not just allow it to be true. So that's what we have here. It allows it to be true, but it doesn't require it. So this argument is invalid. So that's that step. Now, if an argument is invalid, then it must have committed some fallacy. So let's check our fallacy, our list of fallacies. So we have 3 groups three. Generally, I group them. I call them three rules, and so they're rules about things, right? So the first is about the existential fallacy. Well, we don't have that obviously because we don't have all universal premises with a particular conclusion. If we don't have that, we also don't have a conflict between the Aristotelian and Boolean interpretation. So all is well on that front. Now, what about negation? Remember, the rule for negation is if there is a negative at all, then there has to be exactly one negative premise and a negative conclusion. And that's exactly what we have. We have one negative premise, that's the O in the major premise, and we have a negative conclusion. There's only one conclusion. So we have a negative conclusion. So it follows the pattern just like it should. If there are any negatives, you have to have a negative conclusion and exactly one negative premise. So we don't have any of the fallacies associated with negations, like affirmative conclusion, negative conclusion, or exclusive premises. So what about distribution? So the distribution has two parts. One has to do with the middle term. The middle term must be distributed in at least one premise. So let's look at it here. Let's start with the minor because you'll see why in a minute, okay? In the minor is an A, and the distribution pattern is a distributed subject, undistributed predicate. So that's potentially a problem because the rule is the middle term must be distributed at least once. But look at the major premise. In the major premise, which is an O, the distribution pattern is the opposite. It's undistributed subject, but distributed predicate. So there you go. The middle term is distributed at least once, so it's not that. Now we have the illicit process fallacy. So here's how they work. If a term is distributed in the conclusion, then it must be distributed in its premise. Otherwise, you have a fallacy. So let's check. The conclusion is an O. The pattern is undistributed subject distributed. S, the subject, doesn't trigger the fallacy at all because it's not distributed. So remember, the rule is if a term is distributed, then it must be in its premise. But if it isn't distributed, it doesn't trigger the rule, so you don't even have to look, right? But the predicate term does trigger the rule because it is distributed in the conclusion. And when we look up here at the premise, it turns out that it's not distributed. So this is, technically we call this the fallacy of the illicit process of the major term. But nobody really says that. What we say is illicit major. Illicit major. And that's what we would do with this type of problem. The second problem set of the syllogisms is exactly like this, only the difference is I give you a mood and figure and ask you to go backward the other way. So what we're going to do is one of those, since they're substantially the same type of thing, we'll do one of those. Let's see, where are we here? That's the one. Okay. So now I think I'm in the right frame. So we'll turn now to section 2.2 on the exam. In this section, you have, I give you a mood and figure, and you have to reconstitute the schema, do the diagram, assess validity, and if the argument's invalid, give the fallacy committed. So let's have a look. Let's do number 2. Number 2 is EAO1. So to reconstitute, basically, we're going to put these in order like this. So major, minor, conclusion. Conclusion's always the same, so we know how to fill that in. Some S is not P, because it's an O. Because we have the first figure, we know where the M's go. They go in this shape. P is always in the major. S is always in the minor premise. And now we just fill in the quantity and quality. So we have no M is P. All S is M. Therefore, some S is not P. Okay, good. So the next move then, after we've determined the schema, is let's do a diagram. So Remember from your, you may have already noticed that we have that pattern, right? All universal premises with a particular conclusion. So we could go ahead and skip straight to that. On the Boolean interpretation, we've got an existential fallacy. So that takes care of that. The question is, what do we have on the Aristotelian interpretation, right? So we go through the process of diagramming, except we also need to diagram x's for the propositions because we need to look at the complete Aristotelian interpretation. So we'll start with the shading, as we always do. We need to shade no M is P, so we shade the region of M overlapping P, just like this. We also need to shade all S is M, that's this region of S outside of M. We'll shade like this. Okay. So that's our shading for the two premises. Now we have to do some X's, right? So now think about this. E's on the Aristotelian interpretation not only have that shading in the middle, but they also have an X to represent the subject and the predicate term. In this case, the subject is an M and the predicate is a P, right? So this is shading. So we need to get these X's on the diagram. And while we're looking at things, let's look at the diagram. That's going to be S and M. So we have all S is M. That's this region right here. And just as we saw on the problem set about immediate inferences, if we have an X here, then it's both at least one S and at least one M. So we're set on the X's, right? With just the one. So the trick now is going to be to get these X's on the diagram with three circles, right? So we're going to just do the same thing we do with the standard Boolean interpretation. We've done all our shading, so the next thing to do is look for definite X's. So ask yourself, is this M right here, the M that is not a P, is that M a definite X? And the answer is, we don't know where it goes. It might be in the region of M outside of S, or it might be in the region of M inside of S. The only thing we know for sure is it's not a P, so it has to be outside of P. So that's an indefinite X. We got to come back to that one. What about P? This is a P that's not an M. Notice because of the shading we've already put on, we know that the P that is not an M cannot be in this region of S overlapping P because it's empty. So that is a definite X. We'll put it right there. So that one is done. Now we need to add an S that is an M that's going to be in a region that will also be an M that is an S, right? So what region might that be? Well, there's only one piece of the region of S overlapping M left because of the shading. So since this region is empty, the X has to go here. And notice this is this X right here. It represents at least one S and at least one M. So we only need that. So we've got this done now. That's done with a definite X. Now let's go back to our indefinite X. After we've done all our definite X's, is there an X on the diagram that can do double duty for an indefinite X? And the answer is yes. This X that we put on to represent the S that's an M is a definite X that can do double duty for the indefinite X we needed for the major premise, which is at least one M outside of P. So there's our diagram. The question then to ask is, does the diagram, with all the X's for the Aristotelian interpretation, require that there is at least one S that's not a P? And the answer is yeah. The X we just talked about, the definite X doing double duty for the indefinite X in the major premise, is that X. That X is right there. It says there's at least one S that is outside of P. And since it's there, it requires that proposition to be true. So on the Aristotelian interpretation, it's valid. Okay, cool. I'm going to post the link to a scan of the key that I made for this exam that shows all the problems worked. And you can use that for reviewing purposes So I hope this sort of walkthrough, I hope that's been helpful to you.